Ever had a workflow fail at 2 a.m. because someone used random third-party action from the marketplace? Today we're going to fix that problem at the enterprise level. I'm Michael Michal, and in this session we're going to focus on GitHub Action Governance, the policies, the runner choices, and the secret strategy that you can scale automation without turning CI/CD into a security incident. Most organizations don't fail at CI/CD because they lack automation. They fail because they can't control it at scale. So when every team is creating their own workflow, pulling random actions, and configuring runners differently, things get messy fast and risky. So in this unit, we're going to focus on 4 areas. We're going to see what actually matters in the real world. We're looking at how to govern actions safely, how to standardize workflows across teams, how to choose and secure runners, and how to protect secrets at scale. Let's get started. When organizations move to GitHub Enterprise, the first big decision is, do we manage the infrastructure or let GitHub handle it for us? GitHub Enterprise Cloud is a fully managed cloud option. GitHub handles the infrastructure, you get the built-in availability and scaling, and you integrate directly with your identity provider. So organizations get centralized user management, better compliance visibility, and less operational overhead. One question is, where is my data residing when I'm on the cloud option? Data residency allows you to control where your GitHub data lives geographically. So for your code, issues, PR, audit logs, metadata, you can choose the region like US or Europe. This is critical for regulatory compliance, data sovereignty, enterprise security requirements. Let's look at an alternative. What about running GitHub in your own environment? If cloud isn't an option for you, then you can use the GitHub Enterprise Services, or GHES. This is the self-hosted version of GitHub. You run it on your own infrastructure, you manage security, backup, upgrades, and you have full control over the environment. This is typically used for governments, financial services, or any highly regulated industries, where cloud hosting might not be allowed. Think of it this way. The GHEC is governance at scale. The GHES is control and compliance. Now we get into the part that actually matters. How do you control what's running on your pipeline? At enterprise scale, actions can quickly become uncontrolled, inconsistent, potentially risky. So GitHub gives you 2 levels of control: enterprise level, global governance, and organizational level for team level flexibility. And this is where you start getting hands-on, controlling actions, restricting usage, and standardizing workflows. So at the enterprise level, there's where things get real. We need to stop developers from running untrusted or risky actions. So by default, anyone can pull actions from the marketplace, for example. But that means unknown code, potential security risks, no governance. So at the enterprise level, you can allow all actions. Restriction to enterprise-owned or creating an allow list of approved actions. What do you want to allow to run into your enterprise and in your organization? If you're running GitHub Enterprise Server, you don't automatically get access to everything in the marketplace. By default, you can include a snapshot of approved actions, but you can choose how much access to allow. You have 2 options: allow marketplace access or manually sync only approved action. And this really matters because in highly regulated environments, air-gapped systems, enterprise that needs full control over dependencies. Now let's move to governance and how organizations standardize workflows internally. Locking down actions at the enterprise level is only half the story. You also need consistency across teams. So without standards, every team creates the workflow differently, store things different places, and use different naming conventions. So at organization levels, you can define where workflow lives, how they're structured, and how teams contribute and reuse them. Think of this like creating a playbook. Shared repo for workflows, naming convention for your CI build.yaml, and clear ownership and maintenance. This is where everything we just discussed comes together. When a developer creates a new workflow, they go through their actions, create the workflow, and instead of starting from scratch, they use the organizational template. They can select a pre-approved template, they can customize it, and immediately follow enterprise standards. So this is how you scale consistently without slowing your developers down. At this point, you might be thinking, there are multiple ways to reuse automation. Which one should I use? Simply think of it this way. It's multiple layers. So we have 3 layers. Reusable workflows for entire pipelines, so you can call from any repos. Reusable actions, which is for smaller building blocks like setup, scanning, or testing. And workflow templates. This is the starter point for your developers when they build workflows. So a quick way to remember: templates, starting point. Workflows, sharing pipelines. Actions, reusing steps. What if you could define your CI pipeline once and reuse it across every repo? A reusable workflow is a full CI/CD pipeline stored in a central repository called by other repository. The key here is workflow call. That's what allows the reuse. So a standard node.js CI pipeline was defined once. Every repo calls it with a few inputs. Now we have consistency, maintainability, and centralized updates. One place that you can make changes, and then that change is going to be affecting anybody that's using that workflow. So how do you actually use reusable workflows? In another repo, you simply reference it. You use the uses keyword. So the uses keyword itself. You point to the workflow path, pass the input and the secrets. It's basically like calling a function, but instead of function, we're calling a CI/CD. The real benefit here is the updated workflow is going to be used once. And if there's any changes, you do it to that workflow, and it's going to be inherent into every other repo that's using this workflow. We've seen reusable workflows. Now let's zoom in on a smaller level. Reusable actions. So these are the individual building blocks of your workflows. They handle specific tasks, maybe setting up the environment, running tests, performing scans. So instead of repeating logic inside every workflow, you package it as an action. How to think about it? Reusable workflows are full pipelines. Reusable actions are individual steps. And templates are your starting points. Same idea, different level of reuse. Governance isn't just about what's allowed. It's about who is allowed to do what. At this level, you control who can run workflows, who can modify workflows, and which actions are allowed. This is enforced through organizational level policies and repository level permissions. So the best practice here is default read-only. Only elevate permissions when needed. Limit who can modify automation. And least privilege reduces risk. Now let's talk about protecting the automation you've already standardized. If you centralized workflows or actions, but anyone can modify them, you lose trust, you can introduce risk, and you can break consistency. This is where you lock things down. So we use branch protection rules. This will prevent from direct commits, require pull request approvals to enforce reviews, and RBAC to control who can make changes. This ensures that changes to shared workflows are reviewed, critical automation isn't accidentally broken, security is maintained at scale. Your automation becomes production code. Treat it that way. Here's the real risk. Every time you use a third-party action, you're executing someone else's code in your pipeline. This introduces a lot of risks, such as malicious code execution, supply chain attacks, accidental exposure of secrets. This is exactly how many recent DevOps security incidents happen. This is why enterprise policy matters. You can allow only trusted actions, restrict usage to approved sources, or block external actions entirely from your organization. You're not just managing workflows, you're managing the security of your entire pipeline. This is where things can go very wrong if not considered correctly. Self-hosted runners. You can choose to run on your own infrastructure, have access to internal systems, and execute information or execute automation code. This means if compromised, they can access sensitive data, execute malicious workflows, and potentially impact your entire network. It's risky. The key risks are unauthorized access, someone runs untrusted workflow, credential leaks from secret exposures, and runners compromised from persistent attack surface. So to secure your runners, restrict which repo can use them. Store secrets in GitHub, not on the machine itself. Use a thermal runner, they destroy after use, and limit runner access within the group. So self-hosted runners are powerful, but they must be tightly controlled. So far we've talked about what's possible. Now let's look at how you actually configure this in practice. At the organizational level, the key challenge is how do your developers move fast without exposing your pipeline to unnecessary risk? In GitHub, this comes down to one critical decision. What actions are allowed to run? You have a few options. Allow all action, least secure, restrict to GitHub or enterprise actions, or define an allow list of trusted actions. In most enterprise environments, you don't want to allow everything. You don't want to block everything either, so the sweet spot is to create an allow list. This allow only verified or explicitly approved actions. Now let's talk about how you actually enforce the governance in GitHub. At the organizational level, the challenge is simple. How do you let developers move fast without opening the pipeline to risk? So, what can you control? Now let's see how we can actually enforce that option in GitHub. At the organizational level, the challenge is simple. How do you let developers move fast without opening your pipelines to risk? So, in GitHub, this comes down to one key control. What actions are allowed to run? You have a few options. Allow everything, restrict GitHub or enterprise action, or define allow list of approved actions. In most real-world enterprises, you want to balance, not fully open, not fully locked down. So the most common approach is allow GitHub verified or explicitly approved actions only. We've talked about reusable workflows and actions. Now let's zoom out and see how enterprise actually organize all this. In real-world enterprise environments, you don't just reuse one thing. You combine multiple reusable components. So a reusable workflows that handles the entire CI/CD pipeline, a reusable action which encapsulates some common tasks, scripts that automate smaller operations. To make this scalable, organizations typically centralize these components, store them in a dedicated repository, and share them across teams. This turns your CI/CD into a platform, not just an individual workflow. The goal is consistency, the ability to reuse and maintain at a scale. Now the big question is, how do you organize all these reusable components in a real enterprise environment? And the key is centralization and separations of concerns. Most organizations create an action repo for reusable actions, a workflow repo for shared pipelines, a script repo for utilities. The structure helps teams find reusable components quickly, avoid duplication, and keep automation clean and maintainable. You're not just reusing code, you're organizing it like a platform. We've talked about building reusable components. Now the question is, how do you distribute them across your enterprise? There are three main ways you can organize distributed actions. You can set them on the GitHub Marketplace. This will make them public, widely accessible, best for open source and external sharing. You can put them on your organization-owned repository. That's the most common for enterprise platform, internally controlled environment. You can set your governance and teams can reuse them securely. Or you can use GitHub packages. These are for containerized actions. More control, strong security boundaries. In most enterprises' environment, you'll primarily use organization-owned repo because you control access, you can enforce security, and you standardize automation internally. So distribution is about balancing accessibility with security. Before we move on, let's quickly cover what good looks like when distributing action across the enterprise. When organizations scale this, a few best practices really matter. Standardization, keeping actions in a single well-known location. Versioning, using versions like V1, V2, and don't rely on latest. Review actions before they are shared. Limit who can modify them. And finally, communicate changes clearly. This is what separates a few reusable workflows from a reliable enterprise automation platform. If you follow these, your automation stays consistent, secure, and easy to maintain. Now let's compare these options side by side, so you know when to use each one of them. The simplest way to think about GitHub Marketplace is that it's best for public sharing and open source. Gives you the least control. Organization repository, on the other hand, is best for internal enterprise use. Gives you strong access control and most common approach. GitHub packages, best for containerized action. If you have a container, go to the GitHub package. Gives you the highest level of control and security. In most enterprise environment, you're going to be used the organizational repository. Packaged are used for stricter security scenarios. The right choice really depends on how much control and security your organization needs. Let's switch from workflows to the infrastructure that actually runs them. We call them runners. Runners are the execution layer for your workflow. At the enterprise level, you're responsible for choosing the right type of runner, securing their access to the runner, and managing how they interact with your environment. Whether you're using GitHub hosted runner or self-hosted runner, the goal is same, reliable and secure execution. In enterprise environment, this becomes especially important because runners interact with internal systems. They run potentially harmful sensitive workloads if they got leaked, and they must follow security policies. To manage runners is really about balancing performance, cost, and security. So what type of runner should you actually use? You have two main options, self-hosted and GitHub hosted. In a GitHub hosted runner, these are quick to start, fully managed by GitHub. All you have to do is choose them and run them. Self-hosted are fully controlled. You fully control them. Runs on your own infrastructure. The choice really depends on the requirement. Simplicity versus control. Standard workloads versus custom environment. In most cases, start with GitHub hosted runners. Move to self-hosted only when you need customization or access to internal systems. Choosing the right runner is about matching your workload to the right level of control. Let's put both runner options side by side so you can clearly decide which one fits your scenario. Here's a simple breakdown. GitHub hosted runners, fully managed, always start from clean environment, no maintenance, and best for most standard CI/CD. Self-hosted runner, full control over hardware and environment. You can access internal system, persistent state between runs, and require you to manage security and maintainability. In most organizations, use GitHub hosted runners by default. The self-hosted runners when you need custom dependencies, internal network access, and specialized hardware. So the decision really comes to the convenience and the control. Another important layer of security when working with runners is controlling network access. An IP allow list lets you restrict access to only trusted locations. For GitHub hosted runners, you allow GitHub published IP ranges. For self-hosted runners, you control exactly which IP are allowed, typically enforced through firewalls and network rules. This is especially important when your workflow interacts with internal systems, or when you need to meet strict security or compliance requirements. So this is about limiting access. Only trusted systems can communicate with your runners. Another important layer for security when working with runners is controlling network access. So an IP allow list will allow you to restrict access to only trusted locations. You specify those IP addresses and you enforce them. You set the ranges of the IP address as needed. This is important, again, whenever you have your runners running important data or needs to communicate with secure system. So only trusted system will communicate with your runners, and you configure that. Let's bring things together. When managing runners at scale, a few best practices you need to keep in mind. Restrict access to runners. Only trusted repositories and team. Use runner groups. That's when you can segment across projects. You can group them together. You can label them. Avoid long-lived runners. Prefer ephemeral runners when possible. Those are the self-destruct, so they don't hold any data after use. Never store secrets on runners themselves. And monitor and audit runners, because tracking workflow execution and access is essential. These controls are essentials because runners execute your workflow. That means they have a direct entry point into your systems. Secure the runners, and you secure the execution layer of your entire pipeline. If you're using multiple self-hosted runners, things can get messy fast. This is where runner groups becomes essentials. Runner group lets you organize and control how self-hosted runners are used across your organization. With runner groups, you can control which repository can use specific runners, assign runners to specific teams or workloads, restrict access based on workflows or environment. Instead of giving every repo access to every runner, you create controlled pools. For example, you can reserve high-memory runners for Delta workloads, limit production runners to development workflows, or restrict sensitive runners to trusted repository only. So runner group gives you both control and isolation, which is critical at enterprise scale. For more information on runners, go to aka.ms/learn. Everything we've built so far, workflows, runners, automation, all depend on one thing: how securely we can handle secrets. In GitHub Actions, secrets are used to store sensitive data like API keys, tokens, credentials. These secrets are encrypted at rest by default, injected only at runtime, and never exposed in your code. That's the best practice. So at the enterprise level, secret can be managed across multiple scopes: enterprise, organization, repository, and on the environment level. The goal is centralize secret management, reduce duplication, and control exactly where secrets can be used. Secrets are the foundation of securing your automation. Managing them centrally and giving access to them carefully is essential. Not all secrets should be treated the same. The key is following where they belong. In GitHub Actions, secret can be scoped at different levels, depending on where you need them. Enterprise level, that means the secret is needed across the entire organization, entire repositories. Organization level, that means shared across multiple repositories. Limited to a single repository, add them to the repository level secrets. An environment, if they're restricted to a specific environment, like staging or production in one of your repositories. So the goal is to follow the least privilege. Give access only where it's needed, and don't expose secrets more broadly than necessary. The tighter the scope, the lower the risk. Always choose the minimum access required. Let's reinforce a few key principles when choosing the right scope of secrets. When managing secrets at scale, 3 things matter the most. Enterprise level secrets, value shared across the entire organization. Scope organization secret carefully so that only repositories that need them have access to them. And finally, use environment level secrets to separate staging and production access. This is how you reduce risk. Smaller scope means smaller blast radius and better control over where secrets are used. So always choose the lowest scope that still meets your needs. Let's move from theory to practice. How do we actually manage secrets across the organization? At the organization secrets, It allows you to centrally manage sensitive data across multiple repositories instead of duplicating credentials in every repo. You store the secret once, control which repository can use it, and manage access to one place. This is especially useful for tokens and enterprise-wide integration. The approach will reduce duplication, simplify rotation, and give you better control over access. So organization-level secrets, they turn into secret management, into centralized, into a scalable process. And let's zoom all the way in. Secrets at the more granular level, the repository. Repository-level secrets are scoped as single repository. That means only workflows in that repository can access them. The idea that repository-specific credentials can be used by that, and it will limit the exposure of those secrets across projects. You can create them directly in your repository settings under Secrets and Variables in Actions. This is perfect when a project has its own development or deployment credentials. A microservice needs its own API key, or you want strict isolation between teams. The most specific the scope is, the more control you have. Repository secrets have you fine-grained security. Now that you've created repository-level secrets, let's see how you can manage them effectively. At repository-level secrets, they are fully managed within the single repository. You can create, update, delete directly from that repository settings. This will limit their use to a certain workflow in the repository, and you can manage them through the UI or automation tools like GitHub CLI. This gives teams flexibility while keeping security tightly scoped. In a real-world scenario, team manages their own secrets. Updates are localized and sensitive values stay isolated per project. So repository-level secrets give teams control while maintaining strong isolation and security. Now that we stored secrets, let's look at how we can actually use them. In GitHub Actions, secrets are accessed using the secret context. This means secrets are injected at runtime, used in a workflow steps like authentication or deployment, and never exposed in plain text. Workflow typically reinforce them using secrets.secret_name, which allow secure use without exposing the actual value. This is how your workflow authenticate to the API, deploy application, and interact with external systems securely. Secrets should only be used when needed and always handled securely within workflows. GitHub secrets are powerful, but many enterprises also go a step further with external vaults. External vaults such as Azure Key Vault or HashiCorp Vault gives you several advantages. Centralized secret management, one place to manage all credentials across systems. Automated secret rotation reduces risk from long-lived credentials. Audit logs, full visibility on what's going on. And least privilege access. This is typically important in enterprise environment. When compliance is required, security teams need visibility, and secrets and sharing across multiple different platforms is happening. So third-party vaults extend GitHub security model into a full enterprise grade for your secret management strategy. And now it's your turn to do the hands-on exercise, where you apply what you learn about organization-level security by incorporating them into your GitHub Actions. So, to do the exercise, go to aka.ms/learn-gh-100. All right, now that you've done the exercise, let's do the knowledge check. Which of the following is a feature unique to GitHub Enterprise Cloud? Requires on-premise deployment and infrastructure management, provides centralized user management with identity provider integration, must be installed and maintained by the organization IT team, operates entirely within a private cloud environment. Provides centralized user management with identity provider integration. What actions can you take at enterprise level to manage the use of GitHub Actions in your enterprise instance? Create workflow templates, configure a GitHub Action use policy, manually sync public actions in Enterprise Cloud. Configure a GitHub Action policy. What actions can you take to control self-hosted runners for your enterprise use? Create and add custom labels on your runners, add proxy configurations to your runners after they start, add the IP address or IP address range of your runners at repository level. And the answer is create and add custom labels to your runners. In this session, you learned how to govern GitHub Actions, both at the enterprise and organizational level. You also looked at how you manage GitHub-hosted runners and self-hosted runners. You also looked at creating and managing and scoping your secrets. Thanks for joining us for this session. To continue your learning, watch other videos in this course or explore more on Microsoft Learn at aka.ms/learn.